Good morning, everyone. My name is Derek Donnelly. I'm going to talk a little bit about building forensic apps. I'm going to give you a bit of background on digital forensics because it's kind of complicated, and it helps to understand a little bit how we built applications actually using Xojo. So I have a fair amount of slides here. I'm going to try to run through this fairly quickly. I'm not trying to make you all digital forensic experts, but I want you to have a little bit of background because there are some principles that we have to stick to that are interesting when we're building apps. So to give you a little bit of background, I'm originally from Canada. I was 5 years law enforcement officer. I worked for the Competition Bureau, which is the equivalent to the Federal Trade Commission in Canada. I actually served search warrants in French. I served them in the snow, and I served them in a hockey rink. Very, very Canadian. I was also 5 years head of IT security for Apple Computer. So after leaving Canada, I moved to California, and Apple came after me and basically recruited me. During that time, I was at Apple from basically 98 to 2003. And during that time, Mac OS X was first coming out. When I first started at Apple, they said, your forensic stuff is interesting, but I don't think we'll ever use it. Towards the end, it was pretty much all I did, including I did forensics on Steve Jobs' computer, and I'm still alive today to talk about it. In 2003, left Apple. I wanted to actually do forensics full-time. So I started BlackBag Technologies with two partners. And the idea was to build more tools. I had started building some of these tools when I was still in Canada. Cellbrite, an Israeli company, actually acquired us in 2020, basically just 2 weeks before COVID hit. So we were already working very much remotely. And then we very much all worked very much remotely. But folks in Israel didn't know how to work remotely. They always wanted everyone at headquarters, but we worked quite remotely. I'm an instructor at the Canadian Police College and for FBI CART. CART is Computer Analysis and Response Team. I've always been a Mac guy. Did try Windows once, but I didn't inhale. It's always my joke. Again, being from Quebec, love poutine. Céline Dion did sing at our high school, and she did cry, because she always cries. So, being a federal law enforcement officer, this is one of the questions. How many trained police officers does it take to get a nerd, me, into a bulletproof vest? It takes 3 officers. So, I was a little heavier then, and my bulletproof vest was a little tight. And literally, there's a picture I don't show, which is really embarrassing, where you basically see 3 officers trying to pull up a zipper on this bulletproof vest. And I always say it feels like my Stevie Wonder impression in the back of a police van because I've got my glasses on. So I go out on search warrants quite a bit. I go out with my local PD, which is Santa Clara in California. They still won't give me a gun. That's probably a good idea. But anyways, so the idea here, how kind of all this sort of started building apps on the Mac. Back then, way back then, being on the Mac, I wasn't very big on Code Warrior. I remember seeing this ad, I think it was in the Mac World, it was talking about Real Basic. I wanted to build Macs on a Mac for the Mac. I needed the GUI to look the same on Mac and Windows, and that kind of came later. Most forensic apps at this time, and I'll really date myself, but basically back then in 98 and 97, a lot of the tools were actually DOS-based. So I was actually already dealing with things like Windows and buttons and things like that. I liked building a lot for FileMaker. I did a lot of FileMaker databases, so I liked that environment, and I was looking for something similar. I'm not a great programmer, and needed to use lots of examples, but I was also building prototypes quite quickly. How this all started is in 1998, around the time when Real Basic was just starting, I got a call from OSI. OSI is the Office of Special Investigations of the United States Air Force. A friend of mine there basically said, we had this case, it's classified, we can't tell you what it is, but we need to basically convert a forensic image, which was at that time a tool called SafeBack, and we need to convert it to a raw image. And we need it yesterday. So this is when I basically wrote my first real forensics app in Real Basic. I wrote it in about 48 hours. It was interesting at the time because I said, well, SafeBack is a proprietary format. I don't know how you get that information. About 2 hours later, I got the CEO from SafeBack saying, I've been told to provide you all the information you need. So I had a feeling the case was kind of important, right? So I wrote it, sent the first copy to him. There's a small bug in it, fixed it. They thanked me very much. It was called HFS Converter. And then I never heard about it for years. I don't know what the actual case was. I did finally, about 5 years later, learn of what the case was. It was a director of the CIA who was taking classified information home on a Mac. And it was John Deutsch. He later got pardoned by Clinton. That was actually my first app, what was actually built for. I didn't know it at the time. So some of the apps I built since then, HFS Converter, Image Buster, these were some of the early tools. I started building basically a full suite of tools for different agencies. It turned into the Macintosh Forensic Suite. Later on, when it started BlackBag, it became Blacklight. And at that time, Jeff will probably notice that we brought on Drew Fahey, and Drew Fahey had Mike Bailey and Dave Gargano, who were Real Basic employees at the time. So that's when we started to really expand our forensic capabilities. I later built another tool called Macquisition, a clever term on acquisition, and this was one of the first imaging solutions. Later on, these tools became Inspector and Digital Collector. So one of my big principles is native analysis. You use a Mac to look at a Mac. And this was kind of a big thing because most of the tools were Windows-based, and most of them were basically doing analysis against Windows systems. The Mac had obviously a very different file system at the time. It wasn't NTFS. As you know, things don't translate very well between Mac and Windows when it comes to things like keynotes and pages and things like that. The Mac itself had really good support for different file systems. And there was also some capabilities built in that would make life easier, things like Quick Look and Spotlight. But also one of the big issues is that there's file formats that just don't translate very well. So this is when I started bothering Jeff, and I kept on calling him for about 3 years Geoff. Anyways, and I was very literally doing the translation and Drew Fahey to this day still bugs me and says, well, you'll need to talk to Geoff about that, right? So, and at a Macworld, I finally ran into Geoff, and he corrected me very quickly, I think. And but the thing that was interesting at that time, one of the things I needed with Real Basic, I was dealing with really big files. So imagine this, if you image a hard drive, so let's say you have a terabyte drive, or let's say you have a 100 gig drive. At that time, when we're doing forensic images, we create a byte per byte copy of that drive. So if you have a 100 gig drive, unless you're using compression, you're ending up with a 100 gig file. You might be broken up into small parts, but you got really big files. So at that time, I was working with 2 gig files, but often I would deal with bigger files than that because, again, depending on the size of your drive, you have to image a drive, you get a really, really big image. And at that time, I think that's when I started talking to Christian and different people about dealing with other resource forks and data forks and the capabilities to support larger files. So that was a really big thing to me at the time. We're also dealing with things like resource forks and Apple Double, and remember Stuff It files and Apple Works, Mac Write and stuff like that, Mac floppies. zip disk, jazz disk, magneto-optical, SCSI drives. When's the last time you dealt with a SCSI drive? But is a different type of interface, FireWire. So basically, BlackBag, when we first started, we actually developed a hardware piece, which was a write blocker. So with a write blocker, you can connect a drive to a write blocker, and it allows you to read from it, but it doesn't change the data. It blocks any writing, usually referred to as a write blocker. So we have data everywhere. I tend to view it as, I mean, we have evidence everywhere, right? And there's some of the obvious stuff, right? So obvious devices like a thumb drive, a hard drive, or an iPhone, or routers, or Wi-Fi devices, and things like Alexa and TVs that have the apps built in. Some of the obvious stuff. Gaming consoles. We're used to seeing all this stuff. But it's not so obvious, my fridge now talks to me, right? Open up my fridge, there's a sticker on the inside, download the app, and now I get emails from my fridge. Very lonely fridge, right? So, but it is very odd, you know, to think about this, that, and it's very funny. This morning, as I was getting ready here, I knew my wife was up because I got a notification that the freezer door was open, right? So, I hope one day to seize a freezer or a fridge. I think that would be amazing, right? And it's actually happened. There's been cases where a fridge was actually seized by law enforcement because there's a hard drive, believe it or not, in that fridge. And to me, that would be fascinating. I've actually been on a search warrant where we seized a very large TV. We walked in the door, and this is one of the unfortunate parts of dealing with law enforcement. We walked in the door, and there was child pornography right on the big screen as we walked in. So immediately, we seized the TV. Later on, I think it ended up in a meeting room somewhere. But anyway, that's not my agency. Yes? Was he put on ice? I was saying, I said it would be very cool, right? So to seize it. But yes. So I think it's odd that, you know, that now, to me, when I think of evidence, it could potentially be everywhere, but I'm also trying to tell a story, and this is going to be my theme for the rest of this presentation. You know, I got a vacuum cleaner. Seemed like a good idea at the time, except every time it starts, my wife immediately turns it off. So it's pretty much sitting there, charging very well, but not doing much around the house. I got an Echelon. That also seemed like a good idea, but it's connected to an iPad. But I have other things like an alarm system. I have a garage door opener that talks to me. And I took these pictures just about a week ago, walking around my house. That thermostat talks to me. You know, we started seeing things like AirTags, lots of people talking about AirTags. And my CPAP, I don't sleep very well. I have, what's the word? Sleep apnea. I have really bad sleep apnea. When I had my test done, out of a typical hour, 42 minutes, I'm not breathing. So pretty bad sleep apnea. But it actually talks to me. Now, my wife talks to me too about this because I snore a lot. But anyways, but the sleep apnea, that machine actually has a SD card on the side, and it can email me with results the next day. So I got a water, what do you call them? The sprinkler control. It actually emails me. And there's another little device there that turns on and off lights around the house. Now, the other really big thing that people are talking a lot about now, the true mobile forensics, is your car, right? Your car has an amazing amount of information. And you might have things like CarPlay or the Bluetooth connected. My wife has a Volvo there on the right, and her phone's connected to it. My car's here on the left, it has CarPlay. I've been involved also doing a lot of vehicle forensics, which is kind of a hot thing right now. And it's very, very interesting because we take the approach that if you can't get to the car, get to the phone. If you can't get to the phone, get to the car, right? Because the two are linking. All this information is being shared between the two devices. So, you know, if you're trying to figure out if someone has a certain contact and you can't get into a phone, the car might have that contact. What's interesting too is when we do training, We'll usually rent 3 or 4 cars, and we have built-in scenarios into every car, because the last time people rented the cars have all connected their phones, and all their information is there sitting in the car. Think about that the next time you rent a car. So it depends on the vendor, and when it comes to the vehicles, it's kind of a bit of the Wild West right now, okay? Because they all do the infotainment a little bit different, but mainly it's that infotainment system. A lot of times there's a USB connection, like in Mercedes cars, there's actually a hard drive that's actually been recording everything since it's left the factory, believe it or not. Even if you delete the data. So we're going to talk a little bit more about this, okay? Remind me, because I will come back to this. But it is amazing how much data is sitting in this stuff. So there's a lot of data. There's really a lot of data. Speaking of which, I have a problem with data. I've got a lot of thumb drives. I have really a lot of thumb drives. This is one of my 4 bags. This is 2 of my 4 bags. And I actually calculated this is 347 thumb drives there. And there's 6.29 terabytes of data. And this is 2 of the bags. I still have 2 other bags. Yes, I have a problem. Okay. But I know what's on every drive. Right. Okay. I also have a lot of hard drives, and a lot of hard drives. This is about 1/3 of the hard drives. I took stuff out in the garage and took some pictures of it. Now, keep in mind, I did a lot of digital forensics, and keep in mind that principle. If I'm imaging something, if I have to image a terabyte drive, if I don't use compression, I need a terabyte drive or bigger to actually store that image, right? So we work with a lot of hard drives. It all got better when Fry's went out of business. This was my favorite store. I pretty much spent the weekends there. And after that point, I couldn't buy all the thumb drives I usually bought. So it was a very sad day when they actually went out of business. I was actually interviewed on TV. The owner used to send me a Christmas card, but I don't want to talk about it. But anyways, so what is digital forensics? We're finally getting into it. Some terminology. Very long definition. The use of scientifically derived and proven methods towards the preservation, collection, validation, identification, analysis, interpretation, documentation, presentation of digital evidence derived from digital sources for the purpose of facilitating or furthering the reconstruction of events found to be criminal or helping to anticipate unauthorized actions shown to be disruptive to planned operations. I got to call back my high school counselor and tell her this is what I actually do, because she thought I'd amount to nothing, or that I was going to end up in jail. Another one, cyber forensics, scientific investigation, analysis, digital evidence in such a way that the information can be used in court. That last part is probably the biggest part, right? We do all this analysis, but we have to put this information all together to potentially present it in court. So there's some basic principles here dealing with digital evidence. Is you have to sort of think about it as it is a crime scene, right? You're dealing with potentially a device, a phone, a computer, and you're treating all this as basically as a crime scene. And the big thing is you don't want to be changing tape. When you see a typical crime scene, yellow tape goes up, do not cross. We're trying to make sure we're not contaminating the crime scene when you have a crime. Well, if you have an iPhone and it's on and I do this, have I contaminated the crime scene? I have, right? I've added data. Lifting it up, the GPS and what's the gyroscope? The gyroscope has just recorded an event, right? So we're going to talk a little bit more about phones. But it's really, really difficult to make sure we're not changing the evidence. It's getting a lot more difficult with phones. So the basic process is identification, collection, bag and tag, basically. Once you seize everything, you're putting in bags or things like that. Preservation, examination, analysis, presentation, and reporting. They usually talk to the 3 A's: acquire, authenticate, and analyze. And I'm going to come back to these when I'm going more into detail about the apps. But the main principle is do not alter data, right? And the hard drive, your hard drive might be a crime scene. And again, it's getting harder to do this with cell phones. If you change the data, then you have to really document it, right? And you'll see most police officers, kind of old school, will have that little booklet they open up and they're taking notes, right? And more of this is happening actually on phones. But software can do some of this documentation for you. And it can be really important to basically take those steps to document everything you can, because it takes 2 or 3 years for these cases or more to actually go to court. And your memory will fail you. You say, what were you doing that Monday morning when you were trying to, seize something? So then when we talk about investigations, we talked about the 5 W's: who, what, when, where, and why. And then 1H, the how. How did it happen, right? So when we do these investigations, we're trying basically to answer all these questions. And we may not be able to answer all the questions. And a big part of it is, how did it happen? Did they use a phone? Did they use a computer? Did they use a car? Did they use a freezer, right? But the big part is you're potentially going to have to explain a story in court someday. And when you're in court, it's going to be really difficult to get into some really difficult terminology and also lots of documentation. So when we're getting evidence, the collection of evidence, as I mentioned before, there's full imaging. If you have a drive, you potentially will try to image every byte from that drive, every sector, every block. Then there's full file collections where you potentially go after copying all the files. There's potentially home directories where this happens more in civil cases. You'll go after just to use all the files created in the user's home directory. You don't worry so much about all the system files. But depending on the type of case, let's say you have a malware case or something like that, a system was compromised, then the system files may be important, right? So depending what you need to do. Partial logical files, maybe you just copy everything from the documents folder. Live memory captures, which is very hot, and it's like you capture everything that's in memory because there's things that are not necessarily written to the drive but are in memory. The pictures, screenshots, and live logs. So potentially all those things associated to acquisitions. So when we're imaging every block. But the big part of sort of that authentication too is that there's validation as we hash things. So this is where a lot of crypto libraries come in handy in Xojo, because we have to hash things. So if we create that 100 gig file that contained everything on the drive, we're also creating an MD5 hash of that file. So if we change 1 bit of that image, we should get a different hash. Now, we don't want that hash to change. So especially if you go to court 4 years later, you're hoping that the hash is the same. And you don't want to have to explain why the hash is different. So again, we're trying to make sure we're documenting that. We're doing things to preserve hashes and things like that. The drives keep on getting bigger. And you said there's a good chance if you have a 2 terabyte drive, you're probably imaging that to another 2 terabyte drive or bigger. Okay. One of our first tools, one of the tools I wrote a while back was called Macquisition, and it does all that imaging for us. And this is actually all written in Xojo. The GUI is all in Xojo. And this actually boots from a thumb drive or an SD card, and it actually boots up a Mac. And then at that point, it doesn't change any data. There's specific steps that we make sure everything is read-only. And then we had the capability of imaging it. This is probably used by most law enforcement agencies around the world. And this was all written in Xojo. There's some back-end shell stuff, like we use DD imaging, DCFL. There's certain tools like that. And you can see there, at the end there, I think it's doing an authentication, and there's a hash, there's an MD5 and a SHA-1 hash. So those are typical. This will typically be part of all that documentation. You have to take lots of notes. Your memory is going to fail you. Software can potentially help you with this. You need logs of what you do, document the validations and variations. If something does get written, you have to document those variations. If you do prototyping or test data, you also have to document all that. Again, you might go to court 2 or 3 years later, and then when you actually go get qualified as an expert witness, you have opposing counsel or you have a defense counsel that's basically trying to discredit you the whole time you're on the stand. They're trying to do whatever they can to potentially throw out your evidence. And this is where the chain of evidence becomes particularly important. You basically, if you create that image of a drive, then it potentially goes into an evidence room, and you document when it went into that evidence room, you document when it came out of that evidence room. Every time it goes in and out, it's a log system. And you have to document all that information. So you have to know who had it, on what date, what were they doing with it. Even in civil cases now, pretty much you have to have a full chain of evidence. And this is something that is kind of difficult to teach to people who haven't been in law enforcement, because the chain of evidence, you have, I deal with this a lot of times where like a company gets hacked and the IT guy is all over the servers getting information left and right, and he's leaving his own trail of evidence behind of all the things he potentially modified. It's kind of like when you have a big hack, it's kind of like stop, drop, roll away from the computer and wait for someone else to potentially image it and then maybe start doing some analysis. So how do we put this all into practice? So I was using Xojo and Real Basic a lot for basically testing theories. And sometimes you get a specific artifact, let's say a Safari history or something like that, and that's stored in the SQLite database. Well, how do you go and get that data out? And that becomes really important because, again, keep in mind that later on you're potentially going to have to present this evidence in court 2 or 3 years later. Okay? So I was using Xojo a lot also to very quickly prototype file types. And when I deal with things like SQLite databases and things like that, a lot of the work I could actually do was actually in debug mode. I could obviously run the same code on multiple platforms, which was very important for us. That principle of use a Mac to look at a Mac, use a Windows system to look at a Windows system. Built your own hex viewer and things like that. It's always amazing to see what your computer says about you, okay? And people are always amazed by, if I know nothing about you, but you give me your computer, and I take a look at your computer, I can probably figure out what you like and what you don't like and what you do online and what you do in Safari and what you do with different apps. Most people, once I show that slide, no one wants to sit close to me at lunch. And no one wants to leave their laptop close to me or their phone, right? But it is, I mean, the browsing history, your bookmarks, the apps that have been installed, email, messages, content you create, the pictures, they all tell a story about you. And potentially that story might be used to go to court if we're potentially trying to show something. So if you want to, know a little bit more about your computer, I know you're probably used to like your documents folder, and you're used to your desktop, and you're used to the things you typically see. But how much time do you spend in that /library, right? The library folder, which is intentionally left not visible, right? And most people don't even realize it's there, but there's an amazing amount of content created there, right? Those Plists, all those preference files, all that XML, all that JSON, all that stuff is stored in there. My dad got a computer a few years back, and no matter, he never has any idea where he saves his files. He just basically hits save, and he can always find it with Spotlight. But I'm always amazed how he gets files in the library. I don't know how he does it, because every once in a while he'll save a Word document, and it's in the library folder. I said, how did you get it there? I don't know. But it is, when I look at my data too, I have a habit. This laptop, there's another partition on here. I probably reinstall the OS 2 or 3 times a month on that other partition. because I like to start with like a clean slate, right? A fresh install, no files, and then start building up, like launch one application and see where it's creating the preference file, see what kind of content is getting created in the background. So I image this drive a lot. And I create a lot of files on it. So a file system events can be really interesting. And again, as you launch an app, you want to know what it's creating in the background. What kind of artifacts are being left? And I do a lot of research on basically in my own system. And now after that, there's a lot of interpretation of the data. You know, between OSs, and Christian was talking about, you know, getting different versions of the OS, and, you know, files are constantly changing, right? Things are, there's updates, and then suddenly a SQLite database where you knew the schema really well completely changes overnight when Apple releases a new iOS. Sometimes you make the wrong assumption about an artifact. Sometimes you get the dates wrong, or you interpret a double as an integer 64. You get the encoding wrong. One of the things that was really difficult for us was figuring out APFS before APFS was even documented, right? And we spent a lot of time reverse engineering a file system that had actually no documentation from Apple. And we were one of the first to get out there. And then potentially always show the raw data with your interpreted data, right? Like you potentially might say, this is a total number of seconds. We show it as this date. We'll try to show both side by side, because if we got the date wrong, you always have the raw data that you can go back to and said, we based it based on this raw data. Parsing a file system becomes particularly important. So if you know different file systems, we parse the file system and we get basically under that file system. If you mount a thumb drive, you basically see files and folders. But depending on how that file system was created and the type of file system, there's all kinds of underlying data inside that thumb drive that may help you with doing analysis. So we want to know what's in every block. And sometimes we don't know what's in every block. Some stuff is just not documented yet. APFS actually came out later by Apple, and it was actually fairly well documented about a year later. And when we were parsing it, and when the actual documentation came out, we were about right 98%. There was a few things we were wrong on, but it took an awful lot of work. And there's all kinds of structures that are part of that file system that you just don't typically see. You usually just see the files and folders. So sometimes you're taking some educated guesses. The structures may contain lots of metadata. I'm going to talk a lot more about metadata ad nauseum. So file system, some of the other things that might be there might be journals and snapshots. This is some of the stuff that helps you potentially recover deleted files. And it's getting more and more difficult to recover deleted files. And it's never as fast as CSI Miami, right? So everything happens in 1 hour. Everything happens in 1 year in real life, right? So APFS, NTFS structures, there's stuff there that helps you tell that story. But you really need to know about these file systems, especially if you're going to qualify as an expert witness, because you basically need to know that in this sector, in the master, in these different structures, they'll just quiz you on it to potentially have you qualify as an expert witness, or potentially have you disqualified as an expert witness. So you may need to know where certain pieces of information are stored in exactly what block and what offset from the beginning of that block. A block being a sector, so typical sector might be 512 bytes, might be 4096 bytes, and you need to know that maybe a certain date is stored, 30 bytes from the beginning of that block. And as I was mentioning before, you potentially have to go after, and forensics often, especially on TV or NCIS, they're always recovering these deleted files, right? You're always seeing them recover deleted files. That's becoming more and more difficult, especially with the M1 systems and M2 systems, with the T2 chip, once it came out, we have a lot of, obviously a lot of encryption built in, and that encryption is making it more and more difficult to recover files, because in most cases when a file is deleted, it's still left in its encrypted state. So if you're looking for a JPEG, but the file is actually still encrypted, it's not going to look like a JPEG. And if you don't have the keys, you're probably not going to recover it. SSDs also have aggressive trim. And the trim function, which is part of SSD drive, is potentially reusing that block very quickly. So with M1 and M2 systems, it's becoming more and more difficult to recover deleted files. With iOS, it became even more difficult with phones, because iOS also uses APFS, but because you can't fully image an iPhone. What I mean by that is I talked about, that possibility of imaging every block, every sector. That's pretty much impossible now with the iPhone and with most Android devices. So you get active files, yes. Yes. A lot of that depends on the logs of the phone, okay? We'll talk about a little bit about a few other pieces, because apps are storing stuff in the cloud too. But there's also ways where probably everyone heard about the San Bernardino shooting where in California. And when that happened, there was a big fight between the FBI and Apple about what Apple was going to provide. They were not going to provide some kind of backdoor access into the phone. But what Apple did say is you can execute a search warrant or a subpoena against Apple iCloud, and we'll provide you what we have on the servers. And they did provide that. And so when that iPhone is potentially talking to the iCloud servers, it's potentially storing messages and all kinds of data in the cloud. And Apple said, when you send us a proper search warrant signed by a valid judge in the United States, they will provide you the data that was on the servers. Now, the tricky part is they were actually mostly leaving that content in an encrypted state and wouldn't actually tell you how to decrypt it. They'd actually send you a link to AES 128 and said, use these functions. Right? So we get a lot of calls from law enforcement basically saying, okay, we got the data. About 80% of the data is still encrypted. What the hell do I do with it now? Right? In some cases, the pictures were not encrypted, so they were still getting pictures, but the big thing, usually the SMS database, the iMessage database, was left in encrypted state. Start working on that. That became a new feature in our tool Blacklight, right? And we provide that. You had a question? Or did I cover it? Perfect. Pardon me? To a point. I mean, some apps have been, doing that. You saw a lot of that initially. There was kind of a big talk about that, but you don't see it as much today. A gentleman was asking about steganography, where they take a picture, but then maybe in some of the bits on the outside, they're actually storing a message in there. It used to be hot with intelligence agencies, but you don't see it as much today. A lot of these apps are storing a lot of this information in the cloud, so it's potentially becoming even more and more difficult to actually get the data directly from the phone. And because we can't image the iPhone, we're potentially getting data from the databases. And what's interesting in the databases, especially with SQLite, records are being deleted, but they can still be recovered. So if you've ever looked at SQLite, if you look up tonight, SQLite and vacuum. Vacuum is SQLite database, right? Because there's a lot of content that gets deleted out of SQLite, but it's kind of like the file system. The file is deleted, but it's still there. Instead of dealing with a file, we're dealing with a record, which is still inside the SQLite database. Oh yeah, there's many. So instead of sort of recovering files, we're tending to more recover records inside of one big file, a database. Okay? So we wrote our own code to actually go and recover deleted records from a SQLite database. And then metadata is particularly important. So as I said, as I was talking about before, the missing files, prosecution will ask if this file was found on a drive. Okay, does it exist on a drive? And if it doesn't exist, why doesn't it exist? Because they assume it should exist. And then when you potentially find a deleted file, they say, now we want to know when it was deleted. Well, there's not necessarily a great creation record and a deletion record of when a file is deleted. But potentially, we're trying to recover more and more data from deleted files. They might exist multiple versions too, which is always tricky, especially with plists. Plists are being updated all the time. And most times a new file is being created. So even though you change one key, it's actually changing tons of information in the plist. But there's also the possibility there could be all these other external devices, thumb drives connected to it and things like that too, that might have had the files copied to a thumb drive or to the cloud. So as I mentioned before, SQLite databases, we're doing more and more things where we're actually recovering potentially deleted records or just parsing the SQLite database. If you get a chance tonight, download your Safari history, which is a SQLite database, bring it into Xojo, and start looking at your Safari history inside a Xojo app. It's a pretty simple left join between two tables, and you'll get all the information about all your history. And I'll show, if we have some time at the end, I'll show an example of it. It depends how they do it. So if they delete the file, there's probably a good chance it's properly deleted. It doesn't do a great job of clearing it, okay? And it basically deletes the record and marks the record as deleted, but it doesn't necessarily vacuum it out of that SQLite database. Well, DuckDuckGo can't, in theory, change data inside that SQLite database on your system, right? So, you know, and there's multiple places where you can get the information. Now, there's all kinds of cache files. There's like history files and all that stuff. You can go into private mode, and private mode actually works pretty well. But if you do everything sort of normally in Safari, I know everyone's getting a little nervous right now around me, right? It just sounds like Big Brother. He's making me nervous. That's why I'm wearing a Hawaiian shirt. You know, I'm very relaxed. But so Xojo does a really good job of actually working with these SQLite databases. And I'm in my apps too, I'm using SQLite to actually store that information too, right? So often I'm reading the SQLite data to extract out any information. I store it in my own SQLite database. So here's a little app that I wrote that was basically a Safari history, and basically it does a left join, and you'll see, you know, basically it'll be the domain, the URL, how many visits and stuff. And this, you know, is the basis of what potentially becomes evidence, right? Ultimately, that report, and you'll see that there's a little save to text report, and there's also save to HTML, and that becomes typically the type of evidence I'll present in court. Reading plists are very, very important. You get lots and lots of plists. They're creating content constantly. And if I'm trying to figure out if you ran a certain application, there's probably a good chance it created a plist, right? And when people delete the app, they don't necessarily delete the plist. So I usually can tell when the app was first run by the date of the plist. So again, look at your library today. When you delete apps, they tend to forget the plist. Xojo does a good job of reading XML, JSON here. There's also binary plists, which is one of the tricky ones to deal with. Then there's showing all kinds of media files. CSAM stands for Child Sexual Assault Material, okay? So it's one of the difficult things we have to deal with. And a lot of times, there's pictures or movies of this content, so it's important to read lots and lots of different file formats. And that's kind of one of the difficult things to do when you're dealing with law enforcement. In the presentation yesterday about AI, we've been using AI to do image categorization. We use it to identify skin tone, nudity, We use it to even identify the age of a person. And we also use it for categorization, where it actually says, is this a picture of a credit card number? Is this a picture of a gun? Is this a picture of a car? And we use that categorization because you got to remember, a law enforcement officer comes in and potentially captures all that data from your home directory. There could be thousands and thousands of images. If you can do something to help filter that for the officer, they can get through the case faster. Metadata, so many dates. So the typical Mac file has how many file dates? 7. Creation date, modification date, access date, backup date, metadata date change, last added date, and there's downloaded date. 7 different dates, right? Which again is fantastic if you have to do analysis and if they're there. The path can potentially be important to a file, especially if they put it in a specific folder. And a prosecution often wants you to prove that this specific user did it. Can you tell me that Jeff did this, or Geoff did this, the alternate, or the alternate did this, right? In most cases, I can't tell you that Geoff did this, but I can tell you a story that someone using this computer on a Saturday night was in this user's home directory, ran this app at this time. Timelines, again with these dates, becomes really, really important, all these dates, because you're potentially trying to take all this information that may have occurred over a year or multiple years and try to identify something to a very specific time frame, right? Did something happen on a Saturday night? And what's amazing with computers and Macs and Windows, you move the mouse, there's probably a mouse event, and there's probably a log, and there's probably all kinds of information being written that activity was happening on the computer. Sorry? So with the way the algorithm works for unlocking the face, it's actually, it's not so much, I mean, they use basically distance between the eyes, and there's a couple different points, right? And in theory, no one's supposed to have the same information. But it's not so much facial recognition as in, I've identified all the pictures of you, right? But there is an aspect of facial recognition of how you're unlocking that phone, but it's not the full sort of, someone gave an example yesterday with the AI stuff, and it was recognizing this is Arnold Schwarzenegger, right? That's a different type of facial recognition. So when it comes to sort of timelines and stuff, people have standard sort of patterns too. People tend to do things on certain days at certain times. And it helps you to potentially do the analysis and present these things in court. Geolocation is probably one of the biggest pieces right now. You know, those 5 W's, the who, what, when, where, and how. I'm missing one there. Why. When and where becomes really, really big, okay? And especially with phones right now, it's very, very powerful evidence to potentially show something happened on this phone, and I was in Nashville at the time, right? Because that helps to potentially place your suspect at a certain place. There's all kinds of geolocation information being stored on the phone, like nonstop, yeah. And especially if you start syncing between your vehicle and stuff, that becomes really quite huge. So in our analysis piece, which our main tool, again, this was also written in Xojo, is called Blacklight, and now called Inspector. This is all written in Xojo, and it starts to put together all that information. And it makes it basically easier for the investigator to potentially take all this information, put it into a little bit easier view. So the hard drives keep on getting bigger and bigger, but in theory, the size is, it's more capacity, but the sizes are getting smaller and smaller. SD drives are getting really small. More and more encryption built in, basically encrypted file systems. And sometimes with these investigations, it takes you 48 hours just to image the drive before you're even looking at data. So they're also looking at possibilities of potentially trying to do triage. Instead of looking at every block, let's look at the low-hanging fruit. Let's look at the files that are potentially sitting in the user's home directory. But some of this processing, if you got a 2 terabyte drive, it may take 5 to 6 days to actually process all this data. So your app is running all that time. Potentially you have multiple processes running during all that time. And you're doing things like checking the headers of every file, checking for malware, checking the metadata, extracting the contents hashed. There's all kinds of information being processed to potentially build that story. And then when something fails, and it will ultimately, at some point it will fail, you want to potentially pick up from where it failed and potentially continue working. And then, after all this analysis, there's the reporting. So if you see it, you want to actually be able to report it. Put it into an HTML report, put it into a PDF. All that data that you're basically gathering will probably go into a report. In a lot of cases, the analyst is not the actual investigator. So the analyst is putting together the information, giving it to the investigator, and then the investigator is going to take that information and see how it applies to their case. One of the other things that was very big for us for Xojo is being cross-platform, because the same tool runs on Windows, runs on Mac OS X, and it's almost exactly the same GUI. So if someone runs the Mac version, they can run the Windows version. And apart from certain features, like let's say a quick look on the Mac, everything else is pretty much the same. So multi-platform was really big. Also, what's becoming really important now is the sharing of your data, especially since COVID. Now, law enforcement agencies are not always at the police station. They're doing more and more work remotely, and now people want to potentially share that case, have multiple users connect to the case. The intelligence agencies will have translators that will look at the same case. They'll have people that will be analysts. They'll have all kinds of different people looking at it. So now there's some of these things are actually now happening virtual machines in AWS and things like that, where the whole case is being shared online, which is kind of a little bit mind-blowing, especially when it comes to this is evidence, right? And sometimes very, very sensitive information, or may even contain images of child pornography. And potentially this is information at some point that might be going to court. One of the big aspects for us, at one point, we were actually storing everything in the SQLite database. We had to change our backend to Postgres because we had multiple users connecting to it. And also, in some cases, we had multiple processes trying to write at the same time to one SQLite database. And that doesn't work very well. You can potentially have separate SQLite databases and potentially bring them all together. But at some point, we had to change our backend to Postgres. And when we changed it to Postgres, then it allowed us to actually have multiple users being able to connect to the same database. And then cell phones came, and the cell phones came and changed everything again. So as I mentioned before, data changes very quickly on the iPhone. It's basically not possible to image an iPhone or an Android device. It's most likely a logical collection, so you're going after certain files. Lots and lots of encryption, and like in the San Bernardino case, a lot of times these phones are locked, and you don't have the PIN. So then, like my old company, Cellbrite, they specialize in exploits to potentially bypass that PIN, right? To get into the phone and still get the data. And that's becoming more and more difficult. Usually an exploit comes out, Apple patches it, and it's cat and mouse game, right? So the exploit is maybe good for one model for 6 months, a year. New model comes out, that one's patched. You're kind of looking for the next exploit. And there's a whole industry out there of people selling their exploits to companies to potentially get into those phones. More and more of these apps are storing the information directly in the cloud. So even if you get access to the full phone, the actual data may not even be stored on the phone. And it might be stored in a whole other country. It makes it really difficult. Right? Snapchat, the servers are in a different country. So if law enforcement tries to do a subpoena or search warrant to Snapchat, they're in a different country. So now you have a whole different jurisdiction. And that's become the worldwide issue when it comes to forensics. Yes? There you go. So the jurisdictions are becoming a huge issue, and there's actually MLATs, which are called multilateral treaties, where basically another country can serve a search warrant on potentially a company in the U.S. The FBI will do that, and they have the treaties to potentially do that in other countries. A lot of times these gangs in Russia and stuff like that, they're not very cooperative, or the governments over there are not very, very cooperative. So putting it all together for court, I just have a few last slides here. At some point, you need to convince a jury. With all this content and all this metadata, you'll be questioned about the things you're presenting in court. Often I have to conduct experiments too. Like someone will say, this app is changing it, or it is saving this date at this time. Why, right? So you create some of your own sample data to potentially explain what the behaviors are. Again, you have to be able to back up the story. Presenting the evidence in court, I always tell this, there can potentially be a grandmother on that jury, right? And you don't want to be explaining DNA, like that guy had to explain DNA in the O.J. Simpson case, right? It was very, very difficult. I did a case which was interesting. It was in Seattle, and it involved, it was a child pornography case, and involved, there was 2 employees from Microsoft, and when I was talking technical stuff, heads were bobbing, right? They were understanding. I had 2 grandmothers in the jury, and they were staring straight at the ceiling and not picking on grandmothers. But they get lost in the technical stuff. And that's really difficult because potentially that's a person, if they don't get it, they may not be able to make the right decision. So when you can show pictures, when you can show maps, it puts people at ease. They don't like seeing big spreadsheets of text, right? I always talk about it should look like what it looks like on a phone. If you got messages, take a screenshot of that and show that in court as opposed to taking some text, because it's visual and people understand that. Also, your judge might not be technical. And potentially it just takes one person to potentially throw off a case because they don't understand the information. When we build these apps, not everyone can be a forensic analyst, right? Investigators have limited training. And they have to basically trust your app. You have to build a really good reputation that basically your app is doing this information. The importance of the UI has to be intuitive. I've always said that, if your app needs a manual, it's probably more difficult than it should be, right? Now, a lot of times people still want a manual, especially law enforcement. There's the story of the big burn button. When I was at Apple, their company came in, they were basically showing how they were going to write software and they were going to be burning CDs. And there was this big presentation. They had all these whiteboards, and I was actually there because I had escorted them in. And they had this conference room, all the whiteboards. They had all these designs. Steve walks in, takes a look at them all. He goes up to a whiteboard and he draws one big button and it says burn. So that's your interface, left of room. And the guys that come in from, I think it was like a marketing firm, they just all came out very dejected and basically saying, we wasted an awful lot of time, right? But if you look at some of those apps, sort of that single button, that's why I sort of joke about the find evidence and the panic button, right? But what's interesting with specifically in forensics, that the investigators still want to be trained and they want to be certified, because they want to potentially be the court and going to court and say, I was trained, certified by BlackBag Technologies. Test. I love QA, I hate QA, right? So we're always testing your app, and your apps are constantly changing. The artifacts are constantly changing. So you're potentially going to be, fixing things constantly. And when you have sort of automated QA and things like that, it's never good when you have less results than the previous run, right? If you run it and you've got 10,000 files and now you've got 9,000 files, you probably have a bug, right? Unless the data changed. So I always talk about that. For court also, what's been interesting for us is we've also had to keep all our old versions, because if an old version was run 4 years ago, we may need to use it again and potentially show it in court. This could potentially be particularly difficult and cross-platform. And imagine when I first started writing this, it was just PowerPC and PowerPC Max, right? So I still have some of those old apps. What's interesting too in forensics is that there's many tools out there, and it's really a toolkit mentality. An investigator will probably have multiple tools from multiple vendors. But it's important that you're potentially getting the trust of your investigator to potentially run your tool. So yeah, you had to make money, and our tools are not cheap. Our Blacklight ran $2,800, and then there is annual maintenance. So it does become a bit of a partnership, especially when you start training them early on, when they're starting to do forensics. We had some resellers, especially in some of the countries where there was language issues and things like that. And we spent a lot of time in trade shows. I think that first picture you saw at the beginning where I'm sitting in a DeLorean, that was actually one of our trade shows. The support for us was critical, very, very critical, and people really liked our support, and really we get nonstop, very nice recommendations and really good feedback from our support teams. And we actually kind of empowered them to basically say, do whatever it takes to get them fixed, whatever. And sometimes it's a software issue, but basically they spent a lot of time on calls, probably much longer than most of the industry. And then we also had a lot of training and certification. As I mentioned before, our users a lot of times wanted to be trained and certified. We spent a lot of time going to conferences. Actually, next week I'm going to another conference in Atlantic City, specifically about the digital forensics. The manual. I keep on joking about the manual, but the manual is actually fairly important for law enforcement, because in that certification, they also archived the manual, basically saying, well, the app had this manual at the time when I used it. And we also try to make sure the manual is not just written by developers or just like writers, but actual practitioners, forensic practitioners. The difficult subjects, as I mentioned before, they have to deal with very difficult content. Often we would actually have capabilities to blur the image. So, I think we actually even use one of Christian's plugin for actually the blurring of the image, so that you don't necessarily have to stare at these pictures that can be really, really disturbing. For me, a lot of this really changed when I had kids. When I was first in law enforcement, I didn't have kids. Once my kids were born, it became very, very difficult to do some of these cases. But it also kind of doubled my efforts to potentially help law enforcement, and no one wants to see kids get hurt. This one, it's very controversial right now about dealing with law enforcement and these aspects. That's why I say sometimes it's not very popular, but for me, coming from law enforcement and sort of giving up my badge, but still being involved with law enforcement, I wanted to do a lot of work to potentially help law enforcement, because again, they're underfunded, and they're dealing with really, really difficult cases. So there's some balancing of the privacy aspects too that is always tricky. I'll remind you this, that I have this famous saying, discus duris naquium mentator, which I've actually said in court multiple times. And it translates to hard drives never lie. People lie, not hard drives. And I remind you, don't change your data if you're dealing with this kind of case. That's my email address, macbuddy@mac.com. I grabbed it about 20 minutes before Mac.com went live because I was there at Apple. And then I got in trouble for it because there was an internal system called MacBuddy. But anyways, any questions? I know I'm just over the time. I know our next presentation is going, but I know I threw a lot at you here. And the presentation is also going to be available, right? Yes, yeah, it's still an ongoing thing. Right? I've done some of those. I've done a bunch of celebrity cases, and they kind of burn me out. So they're really difficult. They tend to be really difficult people, and it's typically more civil cases, like nasty divorces and things like that. So I try to stay away from them now. But I have some. Oh yeah, yeah. They're taking pictures of everything and anyone, and they just don't have the concepts of it's there forever type thing. I have not been involved in January 6th at all, apart from the fact that our law enforcement agencies that use our tools have been using it for sure. So some of my most famous cases, I did the African embassy bombing case, where the 5 suspects in New York were all on backs. To this day, I still don't know what I found. It was all in Arabic. So, but at the time, the document. I'll answer your question in just a sec. At the time, the document was in a desktop publishing app called Ready, Set, Go 1, 2, 3. And Arabic is from right to left. And there was no way to actually send this to a Windows system. So I did 4,500 screenshots in that case. It went to New York. Someone would translate it. They'd say, look for this squiggly. I'd translate that to ASCII, run the search again, did multiple searches. Another case I worked on was Cameron Diaz. When she was younger, she took a bunch of nude photographs. Very difficult case to work on. Very difficult. But anyway, someone was extorting her, and I was involved in that case doing the analysis. The photographer it was all on a Mac. Great smoking gun case in this. So it's very funny because he actually faked a consent form. And he actually grabbed a picture, an autographed picture of her, and lifted the photograph and put it on the consent form. The only problem is the person that was selling the picture on the internet faked the signature. We actually found the person that was selling it. And the other part that was really interesting in this case is he said he just scanned the document. It was a Photoshop file, and it had 6 layers. It had the form in the back. It had a layer for the signature. It had the leathering, the weathering. It had everything. It's like, how do you explain that? It was a great case. Sorry. Is it what? It's as far as I know, it is not illegal in any country because it's typically used by law enforcement. Okay. Now understand that also our software is used in civil cases, right? So we do sell to both. There are, at the time, there are certain countries we would not sell to. And sometimes certain resellers we would not sell to also because we knew they were selling to other countries. There weren't, like there's certain countries we're not allowed to sell the software to right out, right? And our software was used by the US government. Yes? So that's that's a really interesting question, right? It changes the data, right? So let's say you have a sector full of zeros, right? Well, that could compress really well to something like the next sector. It could be 5 bytes, 512 0, right? That represents that sector, right? Now, right, exactly, right? So it has been a big subject of controversy for many years, especially at the start. And then there's a couple of forensic formats. One of them is called in-case that has had compression. And most of these tools have an option to compress or not compress. And some agencies will compress, some agencies will not compress, especially when they're running out of dry space, they start compressing. But it was basically an accepted image format where they basically showed that you can potentially restore that image, and anything that was compressed can be brought back to its full size of a sector, right? And because that format was accepted, it's now generally accepted in courts. But again, different agencies do it differently. A lot of times the FBI will do full imaging. They'll just image the whole thing. And there's some cases where, especially if, let's say half your drive is full and the other half is not, you're copying a lot of zeros for nothing, right? And using a lot of space. So in some cases, it makes sense to compress that in, especially when you basically say the next half of the drive is all zeros. That can compress really well. Yes. Yes, especially, so in FS, I talked a little bit about FS events. FS events tracks things like which USB devices are connected, okay? And a lot of these SQLite databases, like the photos database, that can potentially, let's say, you can take a picture on your phone and then it maps to your Mac laptop. That SQLite database will usually tell you from what device it came from. And that becomes critical in some of these investigations because these devices, there's multiple devices, right? They'll go in and seize a whole bunch of devices, and then you're potentially trying to show, did the person download the content or did the person create the content? Which can be quite different, right? It's almost like, did the person buy pot or did they grow the pot, right? Because it can be charged differently. So like the larger agencies, the FBI has massive back-end servers, like whole data centers, right? And to the point now, there's a version of AWS, I think it's called C2S. There's AWS that's now being used by intelligence agencies. The CIA now uses a special version of AWS, which is mind-blowing, right? All the information is classified, right? Yet it's sitting in a data center in another state, and the information is all classified, it's sitting in the cloud. No, not. Oh, it's insane. All kinds of encryption, right? And that's why there's quite a bit of latency too. Anything else? Thank you very much for your time.